Hello. Whenever I see that I've chosen a finance question for myself, I just feel so bewildered. And I want to conjure my former self to ask her why. Why would you do such a thing? This better be good. Anyway, so yeah, this is one of what feels like it's not really a reciting of a finance question anymore on this channel. Like the way these just pop up every so often. Anyway, welcome to another ramble with me. We are looking at a finance question from the department's November 2023 paper 1. Question 6.3. Tino wins a jackpot of 8,600,000. Wow, it is so sad that money doesn't even move me at this point in Cyril's economy. The beloved president. Sorry, can just talk about him like I'm talking about him at a braai in my backyard. I don't have a backyard. I live in an apartment block. I don't have a backyard. Anyway, 1.6 million rand is the cost of a 2-bedroom flat in Cape Town, guys. Like, never mind the fact that money would be taxed, so he wouldn't even afford the 2-bedroom flat in Cape Town. Ha! Anyway, Tino wins this jackpot. I think we must just call it a pot or a jack, but not a jackpot. Anyway, he invests all of his winnings in a fund that earns interest of 11.2% per annum compounded monthly. What? Am I giving first world problems? Like, 1.6 million rand really could change a life. It could. Just not in Cape Town suburbia. Anyway, right, he invests all of his winnings in a fund that earns interest of 11.2% per annum compound. Wow, why am I revealing where I live? Okay, he invests all of his winnings in a fund. He invests all of his winnings in a fund that earns interest of 11.2% per annum compounded monthly. Okay. Wow, what returns are these? Wow. I need this investment ASAP. He withdraws 20,000 rand from the fund at the end of each month. Okay, that sounds so responsible. His first withdrawal is exactly 1 month after his initial investment. How many withdrawals of 20,000 rand will Tino be able to make from this fund? Don't tell me it's going to end. No. Could there be a scenario where the money never runs out? Like, how little would he have to withdraw in order for the money to just keep going? Anyway, right. So on the one hand, in our little timeline, when we're talking in months here, right? I don't really need the months for my first timeline. Yeah, I want 2 timelines. So at T0, we are putting in 1.6 M, and then this 1.6 M grows at 11.2% per annum compounded monthly. These are not official abbreviations, but okay. Right. Then there's a second timeline, right? Where from T1, T2, T3 up until TN, each month there's a minus 20,000 that is happening, and then presumably there's going to come a TN where he withdraws the last 20,000 or whatever. I mean, presumably it won't be an exactly 20,000 rupee. Something slightly smaller than 20,000. Anyway, so you want to look at, okay, what would this 1.6 million have grown to in these N months? But then also minus the 20,000, and not just the 20,000, but the 20,000 and all of what it would have accrued if it had not been removed. So take away the 20,000 and its earning potential, right? So, wow, someone just had a very fierce cough. So if we just look at the withdrawals, okay, if someone is coughing fiercely, this is what's up. Ooh, say what, say what, say what, hey, ooh, girl, you know what's up. Right back to the very first 20,000 that was withdrawn. That had it been left alone would have earned interest for how many months? 1, 2, so n minus 1 months, right? 1 month at T2, 2 months at T3, so it would have earned interest for n minus 1 month. So all in all, there are n withdrawals, right? Okay, so as a geometric series, this is, so let's just write out the geometric. This is not gonna fit. Why you foster kanje, baby girl, unga fosti, so foster. Right, so geometric series looks like that. Okay, so here our A is 20,000, and if you're a fan of the geometric series approach, always remember to start your geometric series from the back. This was always better that way. So 20,000, the 20,000 before that, and so on, as opposed to starting with this one, and so on and so on, because now your A can just be a clean number like 20,000 instead of being a bombastic number like that. Well, bombastic expression. Right, and then the R is 1 plus 0,112 over 12, right? That's what we're timesing with, each term with, each time. And we do have n terms, okay? And then down here as well, we have 1 plus, 1 plus 0,112 over 12, right? So let's just times that out a little bit, simplify kancane. And we can take it a little step further. Dividing by fraction is the same as timesing by the inverse. Okay, so we're timesing with 12 and dividing by 0,112. Yeah, we could just rewrite this as 240,000, and likewise here, if we times the 12 in, okay, right, so this is what the withdrawals would have accumulated, okay, and like if they had just been left in place, and we want that, we want to figure out for which value of n is that equal to what the investment would have grown to if there were no withdrawals. I don't know, man, I don't think I'm making sense, but okay. Here we are. So 1,600,000 growing at 11.2% per annum, for n months, right? And we want to figure out, okay, what is that n that would make this true? Ooh. Need to shrink things. Yeah, it's moments like these where I kind of envy people that understand those future value, present value formulas. And it's like, this could probably be a lot easier, but okay, wow. So I'm gonna times by 0,112 on both sides. I'm just gonna times this one. So that's gonna be 179,200. Yo. And on this side we have this guy. Okay, and then now we've got an unknown n here, so I'm gonna move this to the other side because this is a common factor to these two terms. So that is going to be, in fact, I can just preempt myself and do that, right? Okay, and then we can work out what that is. I will lift up mine eyes to the hills from whence cometh my help. My help cometh from the Lord who made heaven and earth. Right, what does this fraction simplify to? So positive number, because we have a negative divided by negative. Okay, I'm going to keep it in simplified fraction form. Right, and then this is a loggy, my loggy. So n is 100 and n is the number of months. So yeah, so 147, oh, I can't point to the calculator. For 147 months, you will get the full 20k, and then that comma 797, that last month, he is going to get a piece of 20k. Right? I think so. Wow, no, it will actually be slightly more, right? No. Yeah, at the end of, yeah, so actually what will happen is at the 147 months, you will get more than the 20k. You'll get 20k plus a little bit. Right? What's gonna happen? Wait, so what we have now found is that at 147,797 whatever months, the investment will the growth of the investment, or rather the withdrawals, the earning potential of the withdrawals will have caught up with the earning potential of the investment. I don't even know if I'm using this earning potential phrase correctly. Honestly, I could just be abusing it. So if you then, so at month 147, there would still be a little bit of money left in the account. So yeah, what's gonna happen is that if you leave that money in there for the full month, the full 148th month, then it will grow just a little bit over 20,000, and then you can withdraw that. But if you were to withdraw it exactly at 147,797.8 what months, then you would get exactly 20,000 rand. Yeah, okay, that makes sense to me. Right. So what was the question? The question was, how many withdrawals of 20,000 will Tino be able to make? And the answer is he will be able to make 148 of them. Where the last one would be slightly more than 20,000. Right? Wait, let me just double check this thinking of mine. So after 147 months, the value of the investment will be, if you had left it untouched, the value of the investment will be square root. Wow, quite a lot. 6269,148,40 blah blah blah. Right? Then the withdrawals, how much would they have earned? They would have earned, so at that point there will have been 147 of them. Okay, and we have that. Okay, so let's work that out. Okay, so we already have that guy. Next up we have 20,000 times okay, right, so that is 6253,323,75 blah blah blah. Right. So that is at the end of 147 months, what would still be available in Tino's account would be the difference between these two, which is about 16k. Right. And if he left that 16k, how can I get the previous result? Oh no, I want the previous result. Okay, let's just work with estimates. Or I could just type it out. Okay, minus the previous answer. Okay, so right, we have about 15,000. If he leaves that to grow for a full month, okay, then he gets 15.8 8. So he does not get a 20,000. Oh, okay. So where did I get this idea? Which does make sense, really, like, because if he got a whole 4,000 rand from just waiting a month, that is a very big return. Okay, so that does like mess up my mind a little bit, honestly. So what are we saying here? So, okay, yeah, at this point, this is one of those situations where it's like, hey guys, the class is dismissed. Mem is just going through her own things now. So I want to see what is the value at 148 months. Why do I care about that? Okay, I want to know what is the value of the investment. I want to see that really this n makes these two equal, and then I want to think about what that means. I am so confused. Okay, sorry, I'm just confusing myself, because if I minus 147 from this and I times it with 20,000, I will get that number. That was the difference between those two, right? Because, hey guys, so important to remember the meaning of variables, right? The meaning of n is how many withdrawals could Tino get? How many withdrawals of 20,000 could Tino get from this investment? And we found that he could get 147,79 something of them, meaning that he can get 147 full 20,000 rand withdrawals and also 797 of a 20,000 rand withdrawal, which would be 15,000 and something. So my bad, I was being silly. My bad. Okay, that kind of makes a bit more sense to me now. And so I will let this rest now before I confuse myself even more. Bye. Yo, okay, only to forget to actually check the memo, and of course I got it wrong. Mew. Do you know why? Why? Because we can't round this up. Because as explained towards the end of the video, that last withdrawal that Tino would get would not be a full 20,000. It would be a fraction of 20,000. And so the question asked how many withdrawals of 20,000 rand could he make, and in this case he would only be able to make 147 of them, and then get the rest in the 15,000 remaining. Yeah, that would be his last withdrawal. Okay, perfecto. We are out of here. Bye.